Is the 13th, accumulation of change. So in this section, you guys will learn what's defined as the area under a curve. So what I want you guys to understand is under doesn't necessarily always mean under, okay? In calculus, the area under a curve, highlight this, is defined as the region between a function and the x-axis. That's too big. And it even says this, under does not necessarily mean under, below. It means between the x-axis and the function. So for example, let's say we're trying to calculate the area under the curve of this function. So here's the x-axis. So the area under the curve, I want you guys, if you guys have colors, to color in this region right here. So this would be the area under the curve. If our function's right here and the x-axis is right here, the area under the curve is not this, it's the area between the function and the x-axis. So here would be above. Now sometimes the function is kind of, the x-axis is like goes through the middle of the function. So the area of this function is interesting. Here the function's below the x-axis, so the area under the curve is just this part. But it's also this part, so plus this region, plus this region. Okay, does that make sense, guys? Okay. So if we're talking about area under a curve in terms of a real world context, we're looking at a rate of change function. The area under the curve gives us the accumulation of change, which is the topic of this lesson. So for the first problem, it says you are on a road trip and you have your car on cruise control for 4 hours. You travel at 60 miles per hour. How far have you traveled? Okay, personally, I hate cruise control because it stresses me out. Because then you always have to adjust if you guys have never used cruise control before. But cruise control, if you guys don't know, means that your car stays at a certain speed for however long you guys have it on cruise control. So it says you travel at 60 miles per hour for 4 hours. So this graph shows if you're at a constant speed, it's always going to be 60, okay? The x-axis is time, the y-axis is miles per hour. How far have you traveled? So if we didn't have this graph, guys, how could you calculate the answer? Yeah, couldn't you just multiply 60 times 4? But here, because we have a graph, we can use calculus techniques to figure it out. So from 0 to 4 hours, and then our speed is 60. So our rate is 60. So what I'm going to do is I'm going to draw this. So my area under the curve is going to be this shape, which happens to just be a rectangle. So the area is going to be, do you guys agree it's going to be length times width, right? So the length is 60 miles per hour times our width. What is our width? What's our units? Hours. Okay, hopefully this doesn't bring back trauma, some chemistry. What happens to our units? They cancel, so the hours cancel. So 60 miles times 4 gives me 240 miles. Okay. Now, unfortunately, this whole semester isn't going to be that easy where it's just a rectangle. Okay. You guys will learn that we'll be able to calculate the area of anything using calculus, which is pretty cool. So, definition, units for area under the curve. Okay, as you guys just saw, some units cancel, so that happens sometimes. The dependent variable, the dependent unit multiplied by the independent unit. The independent unit is x. The dependent unit is your y. In other words, the units for y multiplied by the unit for x. All right, what you're going to see in this next problem is like what almost all of your assignment is for 6.1. Okay, and I'm actually going to, because I'm so excited, I'm going to teach you guys a new way to write this just to kind of set the stage. The graph below represents the rate at which water is leaking out of a tank. The units are given in the graph. How much water has leaked out of the tank after 9 minutes? Okay, so do you guys agree the units are going to be y times x, right? So gallons per minute times minutes. So what's going to happen? The minutes cancel. So our units for our final answer is going to be gallons. I want to get that out of the way before we forget. Okay? So if I want to know the rate at which, how much water has leaked out of the tank after 9 minutes. So if we look at the graph, the x-axis is minutes, the y-axis is gallons per minute. So I want to know the area under the curve, right? Is this a normal looking function? No. So what we could do is we could break this up into different shapes that we can find the area of and then just add up all the areas. Okay, so from 0 to 9, do you guys agree it's going to be from 0 all the way to this point right here? Okay, so this is what I want you guys to do. If you guys have different colors, excellent. I noticed right away this is a semicircle. Okay, from here to here, I could draw a line right here and that creates a rectangle. And then I have this triangle. Okay, is everybody cool with that? So I have my semicircle. I have my rectangle. And I have my triangle. Okay. So for the semicircle, let's start there. Do you guys agree that the area of a circle, if you guys don't remember, is pi r squared, right? But we're doing half of it. So it's going to be 1/2 pi r squared. So careful. The radius, remember, is the distance from the center to one of the edges. So how far do I travel? 2. So the radius is 2. So it's going to be 1/2 pi times 2 squared. 2 squared is 4. Half of 4 is 2. So the area of this semicircle is 2 pi. Okay, this is the easy one. Area is length times width, so the width is 6. The height is 6 times 2 is 12, so the area of this rectangle is 12. Okay, in calculus, you don't have to show your work for that. I assume that you guys know how to find rectangle area. What's the area formula for a triangle? Sean, what'd you say? The area. Good. Area is equal to base times height divided by 2, or 1/2 base times height. Okay. The base, careful, how long is this base? 3, and the height is 2. So it's going to be 1/2 times 3 times 2. Half of 2 is just 1. 1 times 3 gives me 3. Okay, so the total area. So this is the new thing I want to show you guys. Do you guys agree we're finding it from 0 to 9 minutes? Most of the time, the next problem, we do have a function. I'm just going to call this f of x. Okay, so this is the notation we're going to use. So whenever you're finding the area in the curve, this is exciting. Look excited. Everybody look excited. This is the exciting part. This notation, it's an elongated S. It means integral. This means area under the curve. Where do we start? We start at 0 and all the way to how many minutes? 9. So the integral from 0, pay attention, 0 to 9. I'm just going to call it our function f of x. We always include this. This stands for delta x. I'll explain what that means more when we get into integrals. Equals. If I want to find the area under the curve, I'm just going to add up all these parts. So 12 plus 3 is just 15. 15 plus 2 pi. I'm just going to leave it like that. What was our units from the beginning? Gallons. Okay. All right. One more. This one's actually fast because if we know part A, we know part B. If you look at the notes, my iPad friends, the homework starts on this page. You're not going to do this right now. I'll print it for you guys. A particle is moving along the x-axis at a rate modeled by r of t and shown in the graph below. How far is a particle from its starting position after 10 seconds? So if you guys look at the x-axis, it's in terms of seconds, right? The y-axis is in centimeters per second. So if I multiply this times this, what's going to cancel? The seconds. So the units for our answer is going to just be centimeters, okay? So what I want you guys to pay attention to is, do you guys see how this part of the graph right here, the area under the curve, do you guys see how this is above the x-axis? And so is this. Notice that from here to here, the area is all below the x-axis. Do you guys want to take a guess at what that means about our answer? It's negative. The area underneath the x-axis means it's negative. So we're going to do add this, subtract all of this, plus this to find the total area. Okay? Did somebody say it over there? Oh, I just didn't hear you. Sorry, I'm deaf. Okay. So there's not one right way to do this. Break it up into little areas that make sense. So this is a triangle, obviously, right? Here, I'm going to break this up into a triangle, a rectangle, and then a little triangle. And then here I have another triangle. Okay, so r of t is our function, right? So do you guys agree that if this is like the y, the x would be t? Does that make sense? So if I want to set this up in a calculus way, after 10 seconds, the way that we'd write that is the area is going to equal the integral from 0 to 10 of r of t dt. I'm going to do this fast just because we're running low on time. Triangle. Area is equal to 1/2 base times height. The base is 2, right? Careful, what's the height? 10. So 10 times 2 is 20. What's half of that? 10. So it's going to be 10. And then all of this is negative. Okay? So for this triangle, the height is 15. What's the base? 3. So 3 times 15 is 45. Half of 45 is 22.5. Okay? This region's also negative, so minus. Length times width. So 2 times, what's the length? Not 3, careful. 15. So 15 times 3 is 45. So minus, wait, no. Is it 45? Oh, it's 30. 2 times 15, sorry, 30. Sorry, 2 times 15 is 30. This is 1. The height is 15. 15 times 1 is 15. Half of that is 7.5. Okay? Plus, this is 2 times 10 is 20. What's half of that? Because it's a triangle? 10. Okay? If you simplify all of this, you're going to get negative 40. Our units is centimeters. So when we're talking about a particle, remember, if it's negative, that means it actually moved to the left because it's a particle movement is along the x-axis. So we're going to say negative 40 centimeters left. Okay. This part is really easy. How far is a particle from its position at t equals 2 to t equals 8 seconds? So do you guys agree t equals 2 to t equals 8 is just all this negative area? Does that make sense? So all you're going to do is you're just going to combine all the negative parts. So the area is equal to the integral from 2 to 8 of r of t dt, which is equal to negative 22.5 minus 30 minus 7.5. And that is negative 60. Since it's negative, which direction is that? Left. So negative 60 centimeters left.